So, in the end, will the sun be to blame for destroying our planet? Or how about a huge meteorite? Or some kind of disease? Probably not. It seems that life will disappear for a very unexpected reason. Humans, animals, insects, fish, and most microbes will be wiped off the face of the Earth because of oxygen, or more precisely, because of its absence. Recent research has shown that the number of freshwater reservoirs with very low or no oxygen levels in coastal areas is increasing worldwide. Over the past 65 years, 4 times more oxygen-deficient waters have appeared in the world's oceans. What does it all mean? It's likely that life on Earth will vanish much sooner than the sun's energies dries up all the oceans. The end is likely to come in a little more than 1 billion years. But this doesn't mean that the planet will disappear too. The period when Earth is filled with oxygen will make up just about 20 to 30% of the total lifespan of the planet. So we're just temporary guests here. Just think how long that is, 1 billion years. The first Homo sapiens appeared only about 300,000 years ago. That is, the entire history of humanity occupies less than 500,000 years. So relax. 1 billion years won't pass very fast. By that time, humans won't be on Earth anymore. We might master space travel and find a new planet in the vast depths of space. But why can we lose air? As the sun heats up, the planet gets warmer and warmer, and this heat breaks down carbon dioxide, the gas which is necessary for all plants to photosynthesize. Without carbon dioxide, they can't produce oxygen. With a drop in carbon dioxide levels, the methane content will increase, and this gas is quite harmful to us. Now, this all sounds logical, but this is a secondary reason for the lack of oxygen. The real problem is something else entirely. As the sun becomes brighter, it will begin to heat rocks on Earth, such as granite and basalt. These rocks will start to break down faster. When they collapse, they take carbon dioxide from the air, which warms our planet. If there's less carbon dioxide in the air, Earth should become colder. But there's a problem. The sun will shine more, and its heat will outweigh this cooling effect. So even if rocks take away carbon dioxide, the sun will blaze so much that Earth will still become extremely hot. Next, when the sun shines more intensely, it, along with other natural factors, contributes to the breakdown of granite and basalt. These rocks mix with carbon dioxide and water to make carbonates, which go deep into the Earth. This takes carbon dioxide out of the air, which means plants can't make as much oxygen because they need carbon dioxide to do that. Besides, volcanoes release gases, which also reduce the amount of oxygen in the air. So the sun, by destroying rocks, affects what happens inside Earth and controls how much oxygen there will be in the air. In about 1 billion years, the sun will become so bright that no rocks will be able to save Earth from its heat, and the escaping gases will halt photosynthesis and oxygen production. And then, our planet will return to the state it was in about 2.4 billion years ago, to the time when the Great Oxidation event began. And this event was much more important than, say, the first Olympic Games or the appearance of humans on the planet. Billions of years ago, there was almost no oxygen on Earth. Instead, there was a soup of gases, such as nitrogen, ammonia, methane, carbon dioxide, and others. Yes, we have these gases in the atmosphere today, but there used to be a lot more of them in the past. It was difficult for any form of life to originate in such conditions. But after some struggle, it succeeded. At first, Earth was inhabited by the simplest bacteria, including cyanobacteria. They learned how to make oxygen using sunlight, water, and carbon dioxide. These bacteria worked for millions and billions of years and made so much oxygen that it began to accumulate in the air. This was what we now call the Great Oxidation event. It was like a great celebration of life, because with oxygen, new living beings could appear. But by the way, cyanobacteria didn't learn photosynthesis because they were like, oh, let's make oxygen, it's so cool. No, oxygen was just a byproduct. Cyanobacteria wanted only one thing, to get as much energy as possible. And for this, they learned photosynthesis. It helped them store energy using sunlight. They used special pigments to absorb light, and the result of this process was the release of oxygen. This had been going on for hundreds of millions of years, and then, at some point, they made too much oxygen. This oxygen started to spoil other gases that had been there before. For example, it ate a lot of methane. Because of this, Earth cooled down a bit, and the Ice Age began. But that's another story. In short, in a billion years, we risk going back to that difficult time. But let's hope that we'll manage to move to another planet on our spaceships or come up with some other solution. And what'll happen to our home planet next? Will new life be able to originate there without so much oxygen? Well, it's possible, but it'll be much more difficult. This will require another source of energy besides the sun. It can be, for example, hydrothermal vents. And by the way, there are ecosystems on Earth that use this type of energy. You can find one of them in the Mobile Cave in Romania. Imagine a place where there's little oxygen. It's dark. The sun's rays don't reach there. Over millions of years of evolution, a unique and slightly creepy life has developed in this cave. It was first discovered in 1986, and scientists are still exploring this place. The entrance to the cave is just a small hole in the ground. A narrow tunnel goes deep underground. Inside the cave, the air is filled with hydrogen sulfide and carbon dioxide, and there's half as much oxygen there as on the surface. A human can't stay there without a special mask. But for local forms of life, this is home, and they feel great there. There are several dozen species living in the cave, and many of them aren't found anywhere else on Earth. Here you can see strange little monsters, white snails, white spiders, centipedes with long whiskers, transparent shrimp, and even unknown species of leeches. Since there's no light in the cave, all these creatures don't need eyes. They're blind, but they have long sensitive antennae and paws that allows them to navigate in the space. They also have no colored pigment, so all these bugs and spiders are either white or transparent. But if there's so little oxygen there, and nobody does photosynthesis, then how does all this life survive? It's all thanks to the unique bacteria autotrophs. They absorb carbon dioxide and produce nutrients. These bacteria are food for other organisms, and those, in turn, become food for larger creatures. So a whole food chain has been built in the cave, which provides all the inhabitants with food. Evolution has created a unique ecosystem that exists separately from the rest of the world. It's like a small universe that has developed according to its own rules. However, this universe is not expanding, because all living beings here can't live away from hydrothermal vents and autotrophs. Otherwise, where would they get their energy from? But let's imagine that the sun cools down, almost all the oxygen disappears, and the entire planet gets covered with hydrothermal vents. It's dark, and the air is filled with methane, CO2, and other substances. And somehow, life begins. Even people appear at one point. What would they look like? Pale, thin, and blind creatures with very long arms that help them navigate in space. They have pets, large centipedes or cockroaches that move silently on the ground. People are also quiet because they don't have lungs filled with air to scream. There's silence in the world. People communicate through touch. No one travels. Everyone lives separately next to their hydrothermal source. The whole world has turned into a horror movie in a billion years.
Most of those twinkling dots scattered across the night sky seem unreachable. But one of them is Betelgeuse, a star so enormous and nearby that you can see it with the naked eye. To find it, locate the first 3 big dots in the Orion's belt. A reddish star to the left is Betelgeuse. It's one of the brightest stars we can see from Earth. And it's just 640 light-years away. No big deal. Betelgeuse has a blue-white O-type star, which is one of the hottest types to exist. Betelgeuse was scorching hot, reaching temperatures of about 90,000 degrees Fahrenheit. Although that was back in the day, now it's an elderly star, and it cooled down to just 5,800 degrees. You know, vacation weather. Blue-white stars are absolutely massive and burn incredibly bright because they have loads of hydrogen fuel. But they have a price to pay for this glory. They burn through their fuel super quickly. As they age, they transform into red giants. This is exactly what happened to Betelgeuse. It burned through its hydrogen and started burning helium instead. This caused its outer layers to puff up like a balloon, turning it into a red supergiant and making it one of the largest stars out there. Now it's stretching over 700 million miles in diameter. Now it's about 1,000 times bigger than our Sun. If Betelgeuse replaced it, it would swallow up Mercury, Venus, Earth, Mars, even Jupiter. And its atmosphere would almost reach Saturn. But something strange has been going on. Betelgeuse spinning way faster than it should for a star of its size. Huge stars like Betelgeuse are expected to rotate slowly, but it suddenly started spinning at a rate of about 3 miles per second. Thanks to powerful radio telescopes, Betelgeuse's orange-red surface can be seen in detail. That's how we learned that it often changes its brightness. Sometimes Betelgeuse shines super brightly and then gets very dim. This happens about every 400 days. And recently, a telescope called ALMA, which is made up of many antennas working together as one, showed that Betelgeuse's surface seems to be moving unevenly. It's like one side is coming towards us while the other is moving away. But all of it might be a trick of light. Betelgeuse isn't as smooth as our Sun. Instead, it's super chunky. Its surface is like a boiling cauldron. It's bubbling and churning incredibly fiercely. Imagine giant plumes of hot gas erupting from its core, reaching the surface and then vanishing back inside. And these bubbles are bigger not only than the Sun, but Earth's entire orbit around the Sun. These bubbles also rise and fall super quickly, even faster than a spacecraft. And maybe this tricks our telescopes into seeing it spin faster than it really does. Some astronomers also think that Betelgeuse could have swallowed up another star, and this gave it a spin boost. But these are all just theories. Things got even more complicated when Betelgeuse dimmed once again, this time in a pretty unexpected way. What's interesting, it was discovered using a weather satellite. A regular telescope had a hard time seeing Betelgeuse clearly because of Earth's atmosphere. So they used a satellite that normally watches Earth's weather, but can also take pictures of space. As we mentioned, it usually brightens and dims about every 400 days. But recently, it suddenly dimmed by 2.5 times more than ever before. This event got the name the Great Dimming. The first theory said that Betelgeuse cooled down and sneezed out a bunch of material, creating a massive dust cloud. This cloud blocked the view of the star, making it look much fainter than usual. They also noticed something strange happening to that dust. It started behaving differently, which might be a sign that something deep inside the star was causing trouble. Betelgeuse's brightening and dimming cycle now happens faster in just 200 days instead of 400. And to add to the mystery, in the spring of 2023, it started shining even brighter than it normally does at its peak. Why is this frightening? Because Betelgeuse might be preparing for its grand finale, and this wouldn't be very good for Earth. We might be on the verge of a supernova. When massive stars like Betelgeuse run out of fuel in their cores, they start burning different elements like carbon, oxygen, and silicon. Eventually, they end up with iron in their cores. At that moment, everything changes. Adding helium to iron doesn't produce energy like other reactions do. Instead, it sucks up energy. This causes the star's core to collapse, leading to what's called a core collapse supernova. A spectacular, breathtaking show. Supernovas are so bright that they can outshine entire galaxies. But a Betelgeuse supernova would be special. Because it's relatively close to us, it would be so bright that we could see it even during the day. When it happens, Betelgeuse will shine as brightly as a full moon, but all that light will be concentrated in one point. For about 2 months, it will be so bright that you could read a book just from the light of the supernova, even if you turned off all the city lights and had a clear sky. The idea of witnessing Betelgeuse explode as a supernova is truly thrilling. After all, the last time a star went supernova in our galaxy was way back in the time of Johannes Kepler, more than 4 centuries ago. That event, known as the SN 1604 or Kepler supernova, dazzled the sky for weeks. But don't get too excited yet. We're not sure when exactly it'll happen. One study says that the star might be in its carbon-burning phase. If we're near the end of that stage, then Betelgeuse might blow up very soon, during the next tens of years. But it's nearly impossible to determine because during that last phase, the star barely changes at all. Even though Betelgeuse is close enough for us to study its surface, we can't peek inside its core to see what's really happening with it. We might as well be at the beginning of the carbon-burning phase, and in that case, we might have to wait 1,000 more years before that cool supernova. Another study says that Betelgeuse might have less than 300 years of fuel left in its core. They say that Betelgeuse is known to expand and contract regularly, and its pulsation pattern hints that Betelgeuse is much larger than we previously thought. This would suggest that the star is further along in its life cycle and closer to going supernova. Other guesses come from observations of similar stars. For example, a star called VYCMA in our galaxy is thought to be closer to going supernova than Betelgeuse, and it's been dimming steadily over the past century, unlike the relatively stable Betelgeuse. If Betelgeuse was about to go supernova, it would dim steadily and very quickly. Also, historical records suggest that about 2,000 years ago, people saw Betelgeuse as yellow, not red. If that's the case, then we might be in its early last days after all. In other words, we have no idea whether it will go supernova tomorrow or in 1,000 years. We just gotta wait and see. But let's say it goes supernova tomorrow. What happens to us then? The 1987 supernova in the Large Magellanic Cloud showed that the effects from the supernova might be so strong we can sense it even from very far distances. The Large Magellanic Cloud is almost 170,000 light-years away, and we still detected the radiation. It's kinda hard to say exactly what the danger zone is. A rough estimate could be around 100 light-years. Luckily, Betelgeuse won't pose any danger to humans. It's hundreds of light-years away, and its supernova won't influence us in any way. We'll be able to enjoy its supernova beauty without any harm. Living on our beautiful planet might seem safe, but only until you start thinking of all those dangers lurking just around the corner or in the vast darkness of the cosmos. Let's see what may eventually lead to the end of planet Earth. With each new potential threat, it gets more and more terrifying. Consider yourself warned. First of all, let's talk about hypercane. This natural disaster can get really extreme. A hypercane is a theoretical hurricane of unsurpassed power. It would occur if the ocean became overheated as a result of climate change, or a massive volcanic eruption could trigger it. In any case, these conditions would create a hurricane, which, unlike regular hurricanes, would stretch way beyond the lower stratosphere. The speed of such a storm would reach 500 miles per hour. The pressure inside the hypercane would be so low that it wouldn't let it wear out as quickly as other hurricanes. The hypercane could last for weeks on end. But the worst thing? It would likely damage or even destroy part of Earth's ozone layer, and the hole could be the size of the entire North American continent. Then we've got super destructive tornadoes. A tornado is a violently rotating column of air. It usually extends from a thunderstorm and is in contact with the ground. Inside a thundercloud, warm, humid air rises upward, and cool air falls down along with rain or hail. Such conditions can lead to the appearance of spinning air currents inside the cloud. Interestingly, these air currents start out horizontal, but at one point they can become vertical and drop down from the cloud, becoming a tornado. Some tornadoes are narrow, rope-like swirls, but others turn into wild funnels. Tornadoes are ranked with the help of the enhanced Fujita scale. A weak tornado normally lasts for a few minutes and doesn't move faster than 100 miles per hour. The next level is a strong tornado. Such whirlwinds can last for 20 minutes or so and have winds of up to 200 miles per hour. And then we can also have violent tornadoes. Those can last for more than an hour and move at a speed of between 200 and 300 miles per hour. On average, around 1,000 tornadoes occur in the USA every year. There's even a region that got named Tornado Alley. It's a 10-state area in the Midwest, but tornadoes can happen in any state. One of the most destructive natural disasters was the tri-state tornado in the USA. It was the world's longest-lasting single tornado that traveled 220 miles through Missouri, Illinois, and Indiana. At the same time, the average tornado's path is usually no longer than 5 miles. But what if one day, a tornado much bigger and way more powerful than any we've experienced before swiped through countries and continents? It would leave behind total destruction and devastation. And how about a supercell thunderstorm? It's the least common type of thunderstorm, but it's the most dangerous. It's likely to cause severe weather, damaging winds, very large hail, and even violent tornadoes. What makes supercells unique is a deep and persistent rotating updraft called a mesocyclone. Supercells can potentially last for hours and cause great havoc. An asteroid impact could end all forms of life on Earth too. If a space wanderer was large enough, it could cause widespread devastation, like it happened with the 9-mile-wide asteroid from 66 million years ago. It's rumored to have destroyed 3/4 of the planet's plant and animal species, including dinosaurs. Depending on the asteroid's size and the speed of its approach, the impact could lead to massive fires, tsunamis, and the eternal winter effect. It happens when the debris ejected into the atmosphere blocks sunlight and disrupts the global climate. Luckily, we'd probably notice such a large asteroid coming close to our planet with the help of our equipment long before the collision and would have enough time to get rid of this threat. It would be our very own sun that would bring our world to an end. Our star is a gigantic, constantly changing ball of molten gases. Every once in a while, it spews out bursts of energy. Solar flares. They often go hand in hand with something called coronal mass ejections. Those are giant bubbles of ionized gas that can accelerate to incredible speeds. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with the temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. Scientists classify solar flares depending on how brightly they shine in X-rays. You aren't likely to notice the tiniest flares if you don't have special equipment. Medium solar flares lead to fleeting radio blackouts at the poles, but nothing too serious. It's X-class flares people should worry about. They cause the strongest and longest-lasting solar storms. Now, if you had gamma-ray vision, you'd be able to see immensely bright flashes. They occur every day, outshine everything around you, and then disappear again. Those flashes are gamma-ray bursts. One of them could wipe out Earth's atmosphere. The flash that might ruin our planet would most probably be born in a faraway galaxy during a merge of two collapsing stars. It would be immensely powerful and super bright. Still 1,000 light-years from Earth, it'd already shine as bright as the sun. Our planet's atmosphere would try to protect us, but its natural shield wouldn't last. The radiation would be so powerful that it would literally cook the atmosphere. It would create nitrogen oxides that would destroy the ozone layer. Without this layer, ultraviolet rays coming from the sun would be hitting Earth's surface at full force. They would wipe out tiny plankton in the ocean. But these plankton produce from 50 to 70% of all oxygen in the world. So, with their disappearance, there would be a severe lack of oxygen, which would lead to the disappearance of life on the planet. In the end, the heat and ultraviolet light coming from the sun would turn the planet into a huge chunk of rock. And what if we came across a wandering black hole? You might know that a black hole is a region in space where gravity is so powerful that not even light can escape its clutches. Luckily, the nearest to us black hole is 1,500 light-years away. It seems that we have nothing to worry about until we learn about wandering black holes. Now, things definitely get way creepier. If such a black hole entered the solar system, Earth would be doomed. We wouldn't stand a chance against this space monster. In 2020, 13 wandering black holes were spotted not so far away from our planet. But not far away in space terms means around 1 billion light-years away, so we've got some time left. Plus, the possibility of such a disaster is very, very low. One day, a rogue planet might push Earth out of the habitable zone and into an extreme orbit farther from the Sun. Then, the climate all over the planet would start getting colder and colder. Don't forget that the farther our planet is from the Sun, the weaker the star's gravitational pull on our planet is. In the end, our beautiful Earth would get too far away from its main source of light and heat. It would turn into a lifeless piece of rock covered with a thick layer of ice. Or the Sun might expand and turn into a red giant. If it happened, it would change the entire habitable zone of our solar system. The disaster would start with our star running out of hydrogen in its core. This would trigger a chain of reactions, which would eventually lead to the core of the Sun heating up and getting denser. As a result, the Sun would get way larger than it is now. During this transformation, the Sun would swallow Venus, Mercury, and Earth.
What a nice cosmic family. Meet Mars. I bet you've met him before. These two little guys are Phobos and Deimos, Mars' small moons. But it seems like Mars isn't treating the little ones the right way. Phobos and Deimos are believed to be captured asteroids. However, Phobos is gradually moving closer to Mars due to gravity, and it is predicted that it will eventually be destroyed by the planet's gravity within the next 35 million years. I won't be around then. So, I imagine this will result in a ring of debris around Mars, similar to Saturn's rings. However, this process is a natural phenomenon and not an act of destruction by Mars. Apparently, Phobos is getting ripped apart by the crazy gravitational forces of the red planet. But wait, there's more! Phobos has these crazy parallel grooves all over its surface. We used to think that they were from an asteroid crash, but now scientists think they're actually from Mars' intense gravity pulling the moon apart. Talk about a rough ride. Scientists have this wild idea that when a little guy like Phobos gets too close to a big guy like Mars, it starts to stretch out towards it. They call it the tidal force. Phobos is predicted to get stretched out so much that it'll actually break apart. Crazy, right? And the debris from the moon will form a tiny ring around Mars, just like Saturn's rings. Now, some people thought that Phobos' tiger stripes were caused by tidal forces before, but that theory got shut down because the moon is just too darn fluffy. But now, these genius researchers ran some computer simulations and found out that maybe there's a hard shell underneath all that fluff that could create grooves on the surface. But don't worry. At the rate Phobos is going, it's going to crash into Mars in about 40 million years. But if tidal forces are already tearing it apart, it might not even last that long. However, we'll still have the chance to learn more about Phobos. NASA just picked 10 rockstar researchers from all over the U.S. to join the science working team for JAXA's Martian Moons Exploration, or just MMX mission. As NASA-supported participating scientists, they'll be helping JAXA explore the two Martian moons, Phobos and Deimos. And get this, they're even planning to land on Phobos and grab a surface sample. The mission is set to launch in 2024, and we'll get our hands on that sample in 2029. 7 of the lucky researchers will be using the MMX flight instruments to conduct their research. Phobos is a real oddball. It's only 17 miles wide and orbits Mars at a distance of 3,728 miles, to be precise. Now that's way closer than Earth's moon, which takes a whole 27 days to orbit us. But Phobos is in a death spiral toward Mars and is slowly falling towards the planet's surface at a rate of 6 feet every 100 years. But there must be a reason why Mars is acting that nastily, right? What if it's all just because of plain vengeance? Well, okay, picture this. Mars is minding its own business, being all hot and watery like a young Earth. It's got a sweet magnetic field that's protecting it from cosmic radiation and keeping its atmosphere nice and thick. Hey, life is good. But then, at least 20 asteroids, each the size of a small country, come crashing down on Mars like a giant game of cosmic whack-a-mole. One of them even leaves a crater that's almost 2,000 miles wide. Now imagine how Mars must feel with 2 asteroids being its moons after what other asteroids did to the red planet. All these impacts are like a massive punch to Mars's gut, and its already weak magnetic field is knocked out cold. The core gets all overheated and can't circulate properly, which means no more magnetic field to protect the planet. It's like as if you were wearing nothing at the depth of the Mariana Trench. If it were possible, you'd be defenseless and chilly. It's basically what happened to Mars. So now, poor Mars is out there in the cold, unprotected from all those nasty cosmic rays. It's like going outside without sunscreen, not a good idea. But at least we can learn from Mars's mistakes and make sure Earth doesn't have the same fate. Maybe we should start investing in some asteroid insurance. But trust me, the red planet isn't mean at all. It's actually pretty friendly. While Mars may seem to be pretty tough for Phobos, there's something that might be thriving with Mars's help. So get this, a team of scientists found a way to grow rice on Mars. Yep, you heard me right. They used MMS, not the outdated way to send pictures, but a special soil called Mojave Mars Simulant. It's supposed to mimic Martian soil. And here's the catch, Martian soil has these nasty percolate salts that can be toxic for plants. So the team grew 3 types of rice, 1 normal and 2 gene-edited with mutations that make them better at handling stress like drought or salinity. And guess what? The mutant strains were able to root in soil with 1 gram of percolate per kilometer. Take that, Martian soil. But hold up. The rice grown in the MMS didn't turn out as great as the ones grown in regular potting soil. So the team decided to mix 1/4 of the potting soil with the Martian simulant, and looky there, the plants started developing better. Now these scientists aren't just thinking about feeding Martians. They also want to see if their findings can help grow crops in places on Earth with high salinity. And get this, the whole project started when 2 researchers met for coffee and decided to try growing plants together. Well, isn't that nice? I suspect you're about to say, hey, but if you want to grow rice on Mars, you have to ship insane amounts of water from Earth, and it's not easy to quench this plant's thirst. You're right. You need about 449 gallons of water to only grow a pound of rice. But guess what? Scientists made a groundbreaking announcement at the Lunar and Planetary Science Conference in Texas. They found a relic glacier near Mars's equator. That's right, water ice on Mars, even near the equator. This is huge news, and could mean there's even more ice just below the surface. It's not just any glacier, it's a relic glacier that's estimated to be 3.5 miles long and up to 2.5 miles wide. It's like the size of a small town. It's got all the features of a glacier, including crevasse fields and moraine bands. But get this, it's not actually ice. It's a salt deposit that formed on top of the glacier while preserving its shape. So, how did this salt deposit form? Well, it turns out that volcanic materials blanketing the region might have something to do with it. When these materials come into contact with water ice, sulfate salts may form and build up into a hardened, crusty layer. Over time, erosion removed the volcanic materials, exposing the sulfates and revealing the glacier's unique features. This glacier is young, likely from the Amazonian geologic period. That means that Mars has had surface ice in recent times. Who knows what other icy secrets Mars is hiding? But hold your horses, there's still more research to be done. Scientists need to figure out if there's still water ice preserved underneath the salt deposit, or if it has disappeared entirely. And if there is still water ice at shallow depths near the equator, that could have major implications for human exploration. Imagine being able to extract water from the ground at a warmer location. That would be a game changer. So let's see what else these scientists uncover about our favorite red neighbor. Maybe someday we'll even get to visit that salt glacier statue in person. See you next time.
Now, what would Earth look like if it was the only planet in the solar system? Or, what would happen to our planet if the moon went missing? Or, what if dinosaurs had never gone extinct? We've all heard the story. Over 66 million years ago, a big asteroid hit Earth. Almost 75% of creatures that roamed the planet at the time were wiped out in mass extinction. Among them, dinosaurs. Tyrannosaurus, Triceratops, Velociraptor, all gone. But because of that, we're all alive. According to science, the human race was developing more safely without these gigantic creatures hunting us. But what if that asteroid had crashed to the ground a few miles away from the place where it fell? What would the world be like today? Imagine walking down the street to your local supermarket and coming across a truck-sized T-Rex. Could that ever happen in this alternate universe we're talking about? Well, dinosaurs would have had to survive a lot more than an asteroid to be living nowadays. About 55 million years ago, the temperatures on the planet rose. The climate became 14 degrees Fahrenheit hotter than it is today. Rainforests flourished, and vegetation was abundant. In this scenario, herbivore dinosaurs would have likely thrived. But they would have started to look a bit different. Plants started growing during that time period were not very rich in nutrients. This means that dinosaurs would have probably shrunk in size, not having the necessary energy to grow all the way to their full size. Then, about 34 million years ago, South America and Antarctica split, which resulted in a cooler and drier climate. During this period, long-legged dinosaurs would have been the ones to survive. At that time, animals had to travel long distances to hunt, since seasons started to affect the availability of food and water. Compared to the mammals of that period, dinosaurs would have had significant advantages, like having more teeth or better eyesight. And speaking of mammals, some of them probably would have never evolved. That would have become dinosaurs' breakfast first. By the way, did you know that some dinosaurs live among us today? Think pigeons, or birds in general. They've all evolved from dinosaurs. Now, I bet you've heard once or twice that we use 10% of our brains. If this was true, what would happen if you used 100% of our brain? Would you be able to compose a symphony? Would you become a tech genius and create a multi-million-dollar company overnight? Let's start with the facts. We don't only use 10% of our brain. This notion became highly popularized by movies, but it's not very accurate. The truth is, the largest portion of your brain is active at all times. But not all parts are working simultaneously. The exact percentage varies from person to person. Now, neurologists say you wouldn't be using 100% of your brain's capacity at once. Your body simply wouldn't have enough energy for that, which means you'd be hungry all the time. Imagine the number of calories you need to consume for that to work. You would also be limited by your body's basic needs: breathing, digesting food, and circulating blood. So if you did use all of the capacity of your brain, you'd be tired all the time. It'd be worse than running a marathon without any preparation. The brain would need all the blood you'd have, which would mean less oxygen for your lungs. Different organs would begin to shut down one by one. In a nutshell, it'd be terrible for your health. By the way, some researchers have estimated that more than 60% of the brain is composed of something that is called neural dark matter. In other words, this dark matter consists of neurons that have no apparent purpose or simply don't respond to common stimuli. Marathons are some of the greatest feats of strength and endurance in the world, but what would happen to your body if you decided to run a marathon without any training? The statistics are overwhelming. Nearly 50% of participants drop out of the race before crossing the finish line. A regular marathon is 26 miles long, and if you're not used to physical activity, it's a great challenge. You'd probably be able to run the first mile without any serious problems, but breathing loudly and heavily through your mouth. By the third mile, your body temperature would skyrocket. and you'd feel as if you have a mild fever. You'd most likely give up here. But if you decided to keep going, you'd have to trick your mind and body into running another 23 miles. By the 20th mile, you'd hit what is known as the wall. Your body would have burned all your reserves of glucose, and you'd get extremely tired. Even experienced runners often go through this stage. By the end of the marathon, you'd be promising yourself to never do this again. You'd leave the race with at least a few cramps and many food cravings. Now picture this. It's a clear, beautiful night. There are no clouds, and you can see two of the brightest planets in Earth's sky blinking up there. Those are Mars and Venus. Now, have you ever imagined what would happen if Earth was the only planet in the solar system? If the other planets never existed, things would be really different for our Earth. The planets in the solar system work together, keeping one another in certain place with their gravitational pull. Now, if Mercury or Venus ceased to exist, Earth would drift closer to the Sun. Our atmospheric temperature would become similar to that on the surface of Mercury, 800 degrees Fahrenheit. This would make life on Earth impossible. But if Jupiter or Saturn disappeared, Earth would most likely drift further away from the Sun, and its temperature would drop to below -200 degrees Fahrenheit. If life managed to survive in such circumstances, it would probably be aquatic. The position of Earth in the solar system not only affects all kinds of life forms, but it also dictates seasons, the length of days, and how long one year lasts. Now, when we say no other planets, we mean no moons either. So, what would happen if one fine day the moon just disappeared? That would have catastrophic consequences. The moon has the largest influence on Earth's tides. In a moonless universe, tides would shrink by about 75%. This would greatly affect crabs, mussels, and sea snails that live in tidal zones. This would consequently disrupt the diet of larger animals. Eventually, it would affect entire coastal ecosystems. Earth's weather would change. Tides and tidal currents help mix cold Arctic water with warmer water from the tropics, stabilizing the climate worldwide. Weather forecasting would become almost impossible, and the average difference between the hottest and coldest places on Earth would become extreme. The absence of the moon would also influence Earth's tilt. Right now, Earth tilts on its axis at 23.5 degrees, mostly due to the moon's gravity. With no moon around, Earth's axis would wobble between 10 to 45 degrees. Scientists believe that even a slight difference in Earth's tilt can cause huge changes, such as an ice age. Other than this, a moonless sky would upend the lives of many nocturnal animals. Moths have evolved to navigate using the light of the moon and stars. Newborn baby turtles use the moon's light to find their way to the ocean. Different animals rely on both darkness and a small amount of moonlight to hunt effectively. Now, how about we travel far back in time and imagine what would happen if you lived in ancient Egypt? This civilization lasted for over 3,000 years. Ancient Egyptians were responsible for building some of the world's most recognizable symbols, the Great Pyramids at Giza. If you'd lived in ancient Egypt, you'd have witnessed a time of enormous scientific and mathematical breakthroughs. Ancient Egyptians organized themselves in strict social structures, so you'd probably have to fit into one of them. You'd have either been born a laborer, a farmer, or a specialist, which was either a soldier, a sailor, or a teacher, or you'd have been part of the Egyptian elite. If you had been a farmer, you'd probably live in a house made of mud bricks. You'd have had a stone oven and kept your food stored in a pit in the ground. You'd have spent your days tending to crop fields by the Nile River, or taking care of cattle and ducks. On tax days, you'd have packed up some of your harvest and brought it to the temple as payment for the usage of land. If you'd been a member of the elite, you'd have spent most of your days in banquets. You would have adorned yourself in gold and semi-precious stones, displaying all your wealth. If you had lived in ancient Egypt, maybe you would have been one of those who invented tables. Yep, before the Egyptians, there was no such thing as a table. This invention appeared as a way to keep food off the ground.
That sound is the explosion of a supersonic wave. The Earth's atmosphere has been invaded by a cosmic rock the size of Everest. It weighs trillions of tons. It is flying towards the Earth at an incredible speed of 12 miles per second. It would fly from New York to Anchorage, Alaska, faster than you can fry an omelet. Don't worry, we're safe. The dinosaurs that ruled the planet at the time, however, not so safe. This was a bad day for them. This disaster began in the area we now call the Yucatan Peninsula, modern Mexico. The meteor did make impact on the ocean, but the water did not extinguish it. The collision caused a huge amount of energy to be released, which began a cataclysm on a planetary scale. Imagine another sun lit up on the surface of the Earth. The initial blast actually blew through the surface. It was as hot as an oven and burned everything in its path. It set up a tsunami as high as the Statue of Liberty from the epicenter. The impact also provoked a colossal earthquake and volcanic activity. Several nearby volcanoes simultaneously released hot lava from their calderas. Millions of tons of ash and soot were released into the atmosphere, poisoning the air. This formed a huge ash cloud in the atmosphere, which for several years didn't allow the sun's rays to reach the Earth. The long nuclear winter began. Only it wasn't snow that fell from the sky, but a rain of sulfuric acid. Yes, it's safe to say that Chicxulub is one of the most devastating culprits in the history of our planet. In fact, why don't we have ourselves a trial against this space monster? Let's investigate this 66 million year old crime. Thanks to scientists' efforts over the years, we have plenty of evidence. I'll be the judge. In the name of space law, I give the floor to the prosecutor. Respected judge, jury, today it is obvious to all that it was this asteroid that led to the extinction of our beloved dinosaurs. Some more beloved than others. T-Rex. There are other suspects. Volcanic eruptions, a lot of oxygen in the atmosphere, a supernova explosion, temperature changes, the list is very long. But scientists have, without a shadow of a doubt, determined the truth. This asteroid left a crater on the planet's surface with a diameter of 93 miles and a depth of 12 miles. Though this scar is hidden under the ocean water, it can still be seen today. The perpetrator did attempt to hide evidence, as the temperature at the center of the collision was so hot it vaporized part of itself, but not nearly enough. We know that lots of asteroids are abundant with the material called iridium. The fragments off this rock contain 300 times the normal amount. And research shows these fragments are exactly 66 million years old, just like the defendant. This is the definitive proof of guilt. Furthermore, the defendant knocked 25 trillion tons of hot rock out of the Earth. The debris of the asteroid mixed in with the Earth's material, and the immense heat turned the stones into glass. Scientists call these tektites. The energy of the impact threw them into the atmosphere, and after a short flight upward, the tektites then fell down upon the Earth. It was like a rain shower, only instead of water, it was a rain of hot fireballs. They bombarded the planet's surface for 24 hours and set fire to everything they fell on. Scientists have found traces of them all over the world. These are undeniably shards of Chicxulub. I rest my case. Respected prosecutor, your evidence is very convincing, but our judgment must be objective. We now give the floor to the defense. Your Honor, I believe this is a terrible misunderstanding. My client isn't some space offender. It's simply the victim of cosmic circumstances. In fact, the asteroid Chicxulub isn't even an asteroid, but in fact the fragment of a comet. These aren't my words. These are the conclusions of a study conducted by a group of astrophysicists at Harvard University. Asteroids are made of stone and metal. Most often they resemble the shape of a potato. Comets, on the other hand, contain rock, metal, and ice. They look like dirty snowflakes with ammonia, methane, and carbon dioxide mixed in. Most comets come to us from the Oort cloud. This is a large accumulation of ice debris around our solar system. Due to the elongated orbit of flight, from time to time, comets emerge from this cloud. So occasionally a cosmic snowball crosses the barrier and enters our solar system. This is what happened to my client. According to scientists, Chicxuloob's flight path put it dangerously near Jupiter, which, with its impressive gravitational pull, accelerated Chicxuloob's velocity and put it on a collision course with the Sun. The Sun's heat then evaporated the comet's outer coating of ice and dust, which formed a tail. But even before making impact, the Sun's gravity shattered the comet apart. One of those fragments was the one that flew through space and crashed into the Earth 66 million years ago. Yes, there is some debate among scientists on this hypothesis, but regardless of the details, one thing is certain. My client did not intend to crash into the Earth 66 million years ago. Circumstances conspired it to be so. You're on. All right, I have listened to both sides, and I've made my decision. In the name of the Space Court, I declare that the defendant is acquitted. Well, that was a bit of fun. The truth is that space rocks like Chicxulub are a dime a dozen. There are millions of them bumping into one another in the vastness of space. The Earth was just unlucky enough to be in the path of this one. Though the impact it's had on the planet cannot be overstated, this catastrophe ended the development of 75% of life on the planet. Some marine animals did survive the impact, for example, crocodiles, turtles, and fish. Of the inhabitants on land, the only animals to survive were tiny creatures, no larger than a modern raccoon. Among them are several species of avian dinosaurs, which are actually the distant ancestors to modern birds. Scientists believe they survived for two reasons. First, unlike most herbivores that relied on grass for their diet, these dinosaurs had beaks, which they could use to split nuts and dig out seeds. So even when most of the plant life was gone, they could still subsist on what's left. Secondly, these dinosaurs' brains were larger than those of most. This means that avian dinosaurs could cooperate with each other and quickly adapt to new conditions. Lots of fungi and mold also survived underground and underwater. Gradually, the darkness cleared away, and ferns began to take over the lifeless landscape once again. Thousands of years later, forests reappeared on Earth. One unexpected benefit to this disaster is that it allowed for the emergence of the rat-like mammals that are the ancestors to modern humans, as well as whales, bears, and even the platypus. Back before the incident, these mammals would live in the shadow of their dominant dinosaurs. But their disappearance created a biological vacuum. Thus, these mammals were able to quickly occupy that vacant niche and become the new dominant group on the planet. According to multiverse hypothesis, many parallel worlds exist simultaneously with our own. Let's imagine that this is true and that we found a way to travel to these worlds. Let's board a ship to fly through space and time. Our destination is a universe in which the asteroid flew past the Earth. In this reality, the domination of the dinosaurs was never interrupted. Earthquakes, tsunamis, ice ages, volcanic eruptions, the dinosaurs survived all these minor cataclysms. Most of the lizards have changed and are now unrecognizable. Due to the onset of the ice ages, many dinosaurs here are covered in feathers that protect them from the cold. Mammals also exist, but they're few and far between. You see some bats in caves, and there are many rat-sized rodents in the forests. During the day, they hide in the undergrowth or in burrows. At night, they go out in search of food. There are no horses, elephants, or other large mammals in this world. Why become large and noticeable if there are so many dangerous reptiles with big appetites around? There are no whales in the sea. There are no parrots, hawks, or pigeons in the sky either. But you can see creatures similar to pterodactyls soaring past. Some are about the size of a helicopter, while others are no larger than a swan. There are also primates, but they're in no hurry to climb down from trees and walk on two legs. In our real world, our primate ancestors settled in the savannah, where, because the distance between trees was much wider, they started walking on the ground between, eventually standing upright and evolving into Homo sapiens. In this world, open spaces are still very dangerous, so these primates stayed in the trees and evolved to more resemble a lemur, not a chimpanzee. So of course, humans have never emerged on this planet. This means there are no roads, cities, cars, or space satellites. But flowering plants did evolve, as did many fruit trees. Many small dinosaurs would have evolved to feed on these fruits. This did also happen in our world, back in the Cretaceous period just before the failed collision of the asteroid with the Earth. The dinosaurs of this planet have grown wiser, reaching the level of a modern chicken. But a large brain uses a lot of energy, and enlarging it is not always a good strategy for survival. What's good for a primate in the mammalian world isn't always good for a dinosaur in the reptile world. Thankfully, this isn't our world at all. In our world, that asteroid really did wipe out the dinosaurs. They didn't stand a chance. What's interesting is it wasn't really the size of the asteroid that made the impact fatal, but where and how it hit the Earth. When measuring meteor impact, one important factor is the angle of incidence, which determines the kind of fallout to expect. Chicxulub hit the Earth at a 60-degree angle. This was the worst-case scenario. At that angle, the impact knocked a lot of water vapor and carbon dioxide into the atmosphere, but more importantly, lots of sulfur. This substance stayed in the atmosphere and formed aerosols, which are tiny particles that blocked the sun's rays. Without the sun, plants disappeared and the climate became colder. If the angle of impact was any different, then the dinosaurs could have survived this catastrophe. As cool as dinosaurs are, I'm glad I can go outside and not have to worry about a random raptor attack or a triceratops stampede. So as devastating as Chicxulub was all those 66 million years ago, I guess I'm glad things played out the way they did. We wouldn't be here otherwise. Thanks for watching.